So in this video we have 3 exercises for you to try, all involving the exponential function. They get more difficult as time goes on, and what I'd suggest you do is you write them down and try them with pen and paper, and then if you come back, detailed solutions will be provided. So see you in a few minutes. Okay, welcome back. On the next slide, I'm going to look at the answer to this question. So this first question is perhaps a little bit cheeky, but it's good practice with powers. So if we look at this, what we have to realise is that this means we have the integral of e to the x all to the power of a half. And that means that we have the integral of e to the x over 2 from the rules for powers. We just multiply the x by a half, and therefore the integral is going to be something like e to the x over 2. We're not going to change the argument of the exponential. And if we differentiate this, we would have e to the x over 2, as we would wish for, but from the chain rule we'd multiply by the derivative of x over 2, the argument of the exponential, and that derivative is a half. We don't have a half here, so we just have to write down a 2, which will mop up the half, and that is our result for this integral. So the integral itself is, I would say, very simple, but it's all about thinking about what the square root means, and that we can write it as a power in this way and use the rules for powers. So with that, let's move on to the next exercise. So in this integral, what we have is e to the x multiplied by a square root of e to the x plus 1. And that looks a little bit complicated until we realise that the derivative of the argument of the square root is going to be e to the x plus 0, so just e to the x, and therefore we have the derivative sitting out here in front. So we have the derivative of a function times a function to a power, and that is something that we can perform by inspection. So what we do is we say this is going to be equal to, and we just leave a bit of space, and then we're going to take this function to a power and we're going to add 1 to the power. So this is currently to the half. If we add 1 to that, we're going to get to the 3 halves. So we're going to have e to the x plus 1 all to the 3 halves plus an integration constant. And remember, we've left a space to tidy this up in a moment. So now, if this is correct, when we differentiate it, we will get the integrand. So let's differentiate this. Obviously, the derivative of this is 0. So we will bring a factor of 3 over 2 in front. We don't have a 3 over 2 here, so we're just going to put a factor of 2/3 there to mop it up. We will then reduce the power by 1. So it's going to go from e to the x plus 1 to the 3 halves to e to the x plus 1 to the half when we subtract 1. And that's exactly what we wanted. And then from the chain rule, we would multiply by the derivative of that, which will give us e to the x, and that's exactly what we want. So this is our result for the integral. And again, it's always worth just pausing, just make sure that you're completely happy with this. So we have this, differentiate it, 3 over 2 comes in front, cancels with 2/3, reduce the power by 1, so we have this to the half, multiply by the derivative of the argument of the brackets, and that's just e to the x. So this is correct, and we can be happy and move on to the next exercise. So this integral here is not one that we can perform by inspection, or at least I certainly can't. So instead, what we're going to do is we're going to introduce a new variable. Now, think about it. If there was here a 1 over root x, which is essentially the derivative of this up to a number, we would be able to perform the integral by inspection, and the answer would just be e to the root x with some number out front. So it would be very nice if we had a 1 over root x there. So why don't we rewrite this integral as the integral of, I'll leave a bit of space, 1 over root x e to the root x dx. Now, of course, at the moment, this is not an equality, it's wrong because we've just introduced this. So what we're going to do is write a root x here as well. So essentially, all we've done is we put a factor of 1 here and written that 1 in this way. Now, this is now in the format of a standard equation that we all love and know. So we have the equation f of u of x times du dx integrated with respect to x is equal to f of u integrated with respect to u, and then at the end we replace u by u of x. So that's the equation that we are using, we're thinking of, and what we have is that u of x is equal to the square root of x. So that is the new variable, and that's a very natural thing to do to try to make this a doable integral. And the reason that we've introduced this 1 here is that this now is the du dx factor up to a number. So let's just get that number right. So u of x is the square root of x, that's x to the half. So du dx is equal to a half, x to the minus a half, so it's 1 over the square root of x. So that factor there is this factor, and we can put in by hand here a factor of a half, and we can put a factor of 2, and again all we've done is we've inserted a factor of 1, but this we now recognise is du dx. So therefore our integral e to the root x dx is equal to 2 times the integral, and now we have a square root of x, but that is u, so we just write the u down. This is du dx, and this is f of u of x, so it's e to the u of x, u being the square root, so we have e to the u, and now this is integrated with respect to u. And we look at this integral and we think to ourselves, we're going to have to use integration by parts. We have something here which, if we differentiate it, will give us 1, and e to the u is straightforward to integrate. So let's say that this is f and this is g prime. So if f is u, the derivative of f is 1, derivative of u with respect to u. G prime is e to the u, so g is the integral of e to the u with respect to u, and that is just e to the u. So now the formula that we're going to use, let's just write it out for clarity, is the integral of fg prime with respect to u is fg minus the integral of f prime g with respect to u. And the choice that we made here for integration by parts is forced on us because this is going to become 1 when we differentiate it and will give us a much, much easier integral. So therefore, go back to our integral, and what we have is that the integral of e to the root x dx is, so it's 2 multiplying it, and the 2 multiplies everything, so we need a big bracket to open. And then we are going to have, from the integration by parts formula, f times g. F is here, g is here. So this is u, e to the u, minus, because there is a minus sign in the formula. And then it's the integral of f prime, which is 1, and I'm not going to write that, times g, which is e to the u, with respect to u, close brackets. So this is 2 times u e to the u is the square root of x times e to the square root of x minus, and the integral of e to the u is e to the u, and again u is the square root of x, close brackets, that's all multiplied by the 2, plus an integration constant. And that is our result for this integral. So what we did here was we looked at the integral. We thought we don't know how to perform it immediately, but if we had a 1 over root x there, we'd be able to use a substitution, and we produce that 1 over root x by inserting a factor of 1, and again I put 2's in here to make it a little bit easier. This is the key formula that we're using. We prepare the ingredients that we're going to need for the recipe. We say what u is, we work out du dx. It's exactly what we needed. And then when we looked at this, we thought, okay, we're going to need to use integration by parts. And the choice of which term to differentiate was fairly straightforward because that becomes very simple. And then we just performed integration by parts and replaced u by u of x, the square root of x at the end everywhere. So that was our answer for this integral. And questions like this level of difficulty is, I think, where you actually need to say u is equal to a function of x and be explicit. Simpler questions, as in earlier, the previous question in this video, I think you should just do them by inspection. Just write the answer down. Okay, on the next slide, I'm going to give you some more related questions and the answers. So here are 3 exercises for you to tackle, and I'd suggest you do them on pen and paper. In a moment, I'm going to pause and then give some hints, and then I will pause again, and then I will give you the answers. So I'd suggest you try them first without the hints. If you need them, look at the hints, and then finally you have the answers to check. Okay, so here are the hints. The first exercise is very much like the first one at the beginning, and you can just do it using the rules for powers. The second exercise can be calculated by inspection. This is the derivative of the argument here. You can just write the answer down. And this one here, this is not the derivative of this, but you can imagine that you'll try to set this as your new variable and that this is related to the derivative. So the derivative of e to the x is e to the x, so you're going to have here e to the x times e to the x from the rules for powers. So you're going to end up needing to use parts. Okay. In a moment, I'll write the answers down. Okay, here they are. So these are the answers, and with that I will stop this video.